Hello, good afternoon, good evening, wherever you are in the world, and welcome to Understanding the Ocean, Tides and Currents with Laura Zulliger. My name is Melissa DeMarie. I will be the host of today's show. I am also the founder of California Water Sport Collective, or Cali Collective for short. Those of you that don't know about Cali Collective, we are a community building organization. And we just happen to use kayaking and paddle sports as our medium to get people together, get them skills, get them technique, and get them out on the water. Really excited about today's program. Laura is the Saltwater Program Director for California Water Sport Collective. So she is in charge of our sea kayaking, surf kayaking, and anything to do out in the sea. So she has a wealth of information, and without further ado, let's introduce Laura. Laura, welcome to the show.
Hello, can you hear me okay?
Yep, we can hear you.
All right, I'm gonna start my video as well. Hello everyone, it's so good to see so many familiar faces that I haven't seen in weeks. So this is a double treat for me. Cool. Well, before I hop in, if it's okay if I go ahead and get started now.
I would love if you got started. Maybe you could tell us a little bit about yourself and your paddling background, your teaching background, and give us a little bit of your background before you dive right into your talk today. Oh, and one quick thing, everyone, just a few bits of ground rule etiquette, things like that for the webinar. Just so you all know, you all be on mute during the duration of Laura's presentation. And while she's talking though, feel free if you have any questions to go ahead and throw those into the chat. And then once we open the floor to Q&A, what I'll do is I'll go back through and figure out who started where and let you guys ask your questions to Laura in person. So without further ado, Laura.
Hello, I've had the honor of paddling with many of you before, but for those who don't know me, my name is Laura Zulliger. And I, as Melissa said, I head up the saltwater programming for Cali Collective. My background, first, I came in through sea kayaking, into kayaking, and then quickly got addicted to whitewater canoeing. And then from there, whitewater kayaking. And then from there, surf kayaking. So I teach in all of those disciplines, but my heart is still very much with the sea. And one anecdote I want to share with everybody that just might give you some frame of reference for how I approach the tides and the currents is I consider tides to be an early babysitter for me. I grew up in coastal Georgia and tend to have a little too much energy sometimes. Some would say I still do. And when I had too much energy, my parents would just take me to the river and let me just swim against the current until I got tired. So I'm intimately familiar with the ways of tides and currents, and they were early babysitters for me. So because so much that we'll be discussing is best understood through diagrams, I have prepared a presentation. So I want to apologize to those who are tuning in by phone, but I'll make this presentation shareable for the follow-up. So I'm going to go ahead and share my screen to begin. All right, here we go. Excellent. So I wanted to go ahead and test. I know a lot of us are coming in with different ranges of tidal knowledge. I know a lot of you have really in-depth knowledge yourself. Maybe some folks are new to sea kayaking and saltwater kayaking and coming from a whitewater background. So I wanted to kick it off with one of my favorite games, Two Truths and a Lie. So here are 3 factoids, if you could say, about the tides. And I'll read each of them for folks who are tuning in by phone. And 2 of them are true, and 1 of them is a lie. So we'll have to determine that. So number 1, the famous biblical story in which Moses parts the Red Sea to free the Israelites from the Pharaoh's wrath can be explained by his innate knowledge of local tides. And he took advantage of an extreme spring tidal event to reveal shoals, allowing people to cross to safety. Okay, that's number one. Number two, Da Vinci was convinced that the Earth's lungs and the tides were caused by the Earth's inhale and exhale, that respiration. He spent years observing the tides in order to calculate the size of the Earth's lungs. Okay. Number three, the Bay of Fundy in Nova Scotia, in Canada's Nova Scotia, experiences the largest tidal range on the planet, where high tide can reach up to 33 feet. Okay. So just think about it. Which one's probably true? Which one's probably a lie? Not that I'm lying to you about anything. Okay, some of you guys may know this factoid. And this is kind of a gotcha, but number three is a half-truth. Nova Scotia's Bay of Fundy can actually experience tides of up to 53 feet, not just 33 feet. So that's quite an incredible range. All right, what is the cause of this? We shall find out. All right, before we get into it, I just want to talk to you and set the scope for what we cover, because there's so much we can cover with the tides. If given 3 hours, I could probably fill it, and it would be tip of the iceberg. So what we're going to focus on in this presentation is understanding the forces that create the tide, namely the moon. Learn about the essential tide-related terms, just so as you're becoming more independent, or even for folks who still have a basic knowledge or even intermediate knowledge, you can start to approach to a deeper understanding with knowing these tide-related terms. We'll explore the relationship between the tides and the currents, and then we'll also determine how tides will influence your paddling, or already do, and then we'll dip into measuring and predicting tides and currents and how they impact your paddling. And I have some secrets that I'll be revealing there that I use all the time. All right. Also on the thing, because the tides can get so complex and they're very multidimensional, especially when you're talking about tidal navigation and starting to apply like advanced math for making corrections and predictions. That's an art into itself. But what I want to acknowledge before we jump in is that we're all still learning. I'll probably be a lifelong learner when it comes to the tides and navigating in tides and currents. And then on a theoretical, conceptual plane, the astrophysicists and oceanographers are still having debates to this day for certain tidal occurrences and events and forces. So there may be a question that is seemingly simple that I've probably asked myself, but the answer is still hotly debated and very complex. So I want to acknowledge that, but also commit to you that if I don't know the answer, I want to hunt it down and share it with you afterwards. So I'm going to do my best, but I'm also still like lifelong learner, as I mentioned. I also have a bias towards the practical. So in traditional navigation, we're taught to predict using math. I think it's a shame to not use the tools that we have before us with technology. So I will cover a little bit of the I guess, analog way to predict, but I also am going to pay equal attention to the digital ways that we have and the digital tools we have at our disposal. But I still want to nerd out with you guys and share some fun tidbits about the tides that I've learned throughout my lifetime. Then one caveat, I don't think we have very many people tuning in from international waters, but just in case, unfortunately, this presentation will be US specific. We will be using imperial measurements. So just keep that in mind if you are applying that to where you live. Okay, so let's get started. What are the forces causing the tide? So for some people, this may be a bit of review. For others, this might be new. But I thought we would start with a little bit skyward, thinking about the orbit of the sun, the earth, the moon, and just understanding that relationship before we add water into the mix, okay? So what you see here in this diagram, a lot of people have the phases of the moon tattooed on their bodies. So, but we have these 4 more main phases of the moon. So of course, we've got the new moon, have a waxing moon. So waxing meaning it's growing, and the sun is illuminating more and more until we reach a full moon, which is the middle diagram there. And then we have it waning in that 4th quarter, that last quarter of the cycle, until we reach a new moon again, okay? So most people know that the Earth, right, takes 365 days-ish to orbit around the sun. But have you ever thought how long it takes for the moon to orbit around the Earth? Right? Some people may know this, some people may not. It takes in between 27 and 29 days. It's not absolute, and it depends on where it is in its orbit and where the Earth is in its orbit around the sun. So it's a pretty complex relationship that we didn't really fully understand until the 1800s, and are still learning more and more. So you also have, so that just to say, like, that's why you have, of course, you know, full moon, and then 28 days later, roughly another full moon, and not back-to-back days of new moon, full moon. Okay? This is pretty basic. But what a lot of people don't know is that a lunar day is different from a solar day. So a solar day, the meridian passage of the Earth around the orbit, in its orbit of the sun, is 24 hours. But yet a lunar day is 24 hours and 50 minutes. So remember this, because this fact will return later. 24 hours and 50 minutes. All right. A lot of interlocking relationships here. Okay, let's add water into the mix. How does that come into play? So one way to think about the tide and the relationship with the moon is that the gravitational attraction between the moon and the Earth causes this bulge, right? The water is lifted towards that gravitational pull from the moon, okay? And there also is some from the sun, but the moon being so much closer, they're infinitely more, you know, not infinitely, 50% more powerful. So that's what's causing this lift. And it's almost, I say the word bulge, but it can be measured almost like a giant wave. It's literally called a tidal wave in ocean physics. I know we associate tidal waves with tsunamis and seismically triggered events, but a tidal wave in a gravitational sense is caused by this lifting from this gravitational attraction. It's actually also called tidal force. Okay? That's part of the linchpin of this attraction. But if you look at this diagram close, and you also have knowledge that, okay, but if there's only one big bulge, there are 2 high tides, so what's the catch here, right? So there's another opposing bulge on the other side. And this is where there's some disagreement among oceanographers and astrophysicists as to what's causing that. Is it the centrifugal force of the Earth causing an opposing bulge on the other side? Or is it the Earth's own gravity squeezing at the poles? We're still learning some of that and testing some of that. But the way that helps me think about it is to dumb it down to just thinking about spinning around in a circle with a water balloon, right? How that water, the balloon stretches and sloshes on the other side. So we're rotating with this gravitational relationship, and there's a bulge where it's being lifted towards the moon, and there's another bulge on that other side, okay? And then the scant water on either side, that's those low tides that we experience, where the water is being displaced by this pull on either side. So something interesting to note is that the tides are really noticeable in a lot of coastal areas, but what people don't realize is at the same time as the water being lifted, the Earth's crust is also being lifted. So when you have a new moon, they've actually measured, like even in Manhattan, you have the cemented city lifts ever so slightly. So it kind of makes you think about the full moon and no moon when people kind of have this erratic behavior and kind of think it's kind of, oh, that's happening. But there's a lot going on there that's affecting the Earth in more ways than we may be able to perceive. So another interesting thing about this is just, yeah, there's so much that we're still understanding about this force. Cool. So here we see the relationship between the moon and that bulge, that tidal wave that it causes, and then also the solar tide. So we know that, or a lot of folks who live on the coast know that when you have a new moon and a full moon, you have your highest highs and your lowest lows when it comes to the tide. But when we have a quarter moon, and in the first quarter and the third quarter, things mellow out a little bit. The highs aren't as high, the lows aren't as low. And that's because we have two bulges happening and they're kind of canceling each other out. So the moon is at a right angle, perpendicular right angle. Not exact. I think anyone who is an astronomer would be horrified by me saying there's a right angle between the Earth, Sun, and Moon. But just for our realm of understanding, I think it's helpful to think about it this way, where there's countering forces here that's pulling counter-gravitational forces. That's like evening out the tide here. So this is also, there's some really interesting things that are happening here when you have that alignment of the sun and the moon, that new moon that we see. That is like doubling up on that gravitational force. And during these events, not every earthquake, but a lot of seismic activity happens when we have these extreme tidal events because of this increased alignment and this increased displacement of volume of the Earth's oceans. Still, people are trying to figure that relationship out. And also something to note is these are monthly occurrences or annual occurrences that happen with the tides. But just like we have solar eclipses and lunar eclipses that happen once every 28 years or once every 1,000 years, there are tidal events too that happen at various time points. So there are a lot of ancient cultures, just like how the Mayans were great astronomers. There are ancient coastal cultures that track time and important events by the tides. So oceanographers have determined that there's even a special tidal event that happens every 18,000 years, right? So that just gives you a sense of the scale of not just what's happening on Earth, but the relationship for our natural forces here and what's happening all around the cosmos. So cool. So some folks may still be with me, but some folks might be like, what's going on? Whoa. You're throwing a lot of terms at me in terms of like, I got the moon, I got gravity, but I'm hearing meridian passages, spring tides, high, low tides. What does all of this mean? So I'm gonna pause here and just give us an index and like a common vocabulary to move forward with regarding the tides. All right, so for some people this might be familiar review, for others it might be new. So we're just gonna move through it. High tide, talking about the up and down volume of the tides. That's what we're focusing on now with this range of vocabulary. High tide, the highest point of that water, the crest of that tidal wave. Low tide, the lowest water point, okay? Tidal range, the difference between low tide and high tide, okay? If we're thinking about it as a tidal wave that's moving around the Earth, another way to think about it, if you're familiar with measuring waves, is going from crest to crest or trough to trough, thinking about wave period. It's another way to think about the tidal range, just like how long is that happening and how big is it there, wave height and wave period. So we also have slack water. So that's this period of time. It can be, some areas don't really, at certain times, don't experience any slack water, but in theory, it's from 0 to 4 minute period of time where the reversing current caused by the rise and fall of the tides is remaining still, or in theory still. We'll explore why this is kind of problematic depending on where you live and how much rain has been happening in the Delta if you live near a mighty river like the forces of the Sacramento here for us in the Bay Area. So you may have also heard about spring tides. Spring tides, as you kind of could depict from the previous diagram, that's when you have an alignment of the moon and the sun doubling up on that gravitational pull. So these tides are your highest highs of the month and your lowest lows of the month. And it can also be for a full moon, right? So the moon is even on the other side of the earth, but that's still doing this gravitational stretching of the earth's oceans. And then the converse of that is a neap tide. And that's when we have that solar tide and the lunar tide, and they kind of counter each other. And a lot of people are curious, spring tide, what's the association with spring? As it happens, there's no association to the season. So they happen every month just about. And it's from Old Norwegian, it's from Old Norse, springa. I hope nobody speaks Norwegian here because this is probably not how they pronounced it. And then the neap is also from Old Norse. I'm thinking it was more pronounced njep rather than neep. So spring tides happen all around throughout the year, not just during spring. All right, more important terminology. So we're getting into level 2 tidal terms. We have also the perigee and an apogee. So in a lot of diagrams, they simplify the moon's orbit around the earth as just this perfect circle. But just like the Earth's orbit around the sun, it's not a perfect circle. In this case, it's an ellipsis, right? So you have those evenings where you look at the moon and you think, it looks really big tonight. Like this is a big full moon. You're not just imagining it, the moon is closer to the earth. When I learned this was a big relief. I'm like, okay, it's not just me. I'm not just like paying that little attention or that much attention. So the moon is closest to the earth in perigee, and it happens once every 28 days. And then following that perigee, again, that lunar orbit, you have the apogee. Think of like apology or opposing, like the apo, it's furthest away. Okay, so keep these in mind. Not only do we have the alignment of the sun and moon for our spring tides and our neap tides, our spring tides, but we also have apogee and perigee. And just a side note, just want to make it clear, when the moon is close to the earth, that gravitational force increases. Some people have measured it to be up to 20%, okay? 20% increase. So what does that mean? It means our e-scooters get wet on the Embarcadero. It means increased flooding in a lot of coastal areas. And this occurrence of what colloquially is known as king tides, right? So that's when there's a lot of road closures. Where my family is from in the Southeast, a lot of roads are no longer compounded with sea level rise. Now a lot of roads close during king tides. And king tides, so already we have our highest tides when the moon and the sun are aligned. Imagine when the moon is closer and there's that 20% additional gravitational force. This is like a tripling up of tidal forces and tidal extremes. Are those king tides. And in the Bay Area, they typically happen in December or January, kind of in that winter phase, and then also in June, July, depending on where the Earth is and also where the sun is in that orbital pattern. And whether you're in the northern or southern hemisphere, it's different too. All right. So we've covered some tide-related terms on the basic tier of high and low, and then we've gone into the apogee and the perigee. Right? Now we're going to do some more terms, the level 3, right? So some people might be familiar with semi-diurnal, diurnal, and mixed semi-diurnal. But let's just explain what they are a bit more. So in most regions of the world, there are 2 highs and 2 lows every day, right? And commonly on the East Coast, the US East Coast, you have 2 highs, 2 lows that are roughly equal. For the most part, on an average day, they'll be within a foot of each other, right? Height-wise, when it comes to that height of the tide or how low they get. But as you've noticed, on the US West Coast, we have mixed semi-diurnal, and that means that you have 2 highs and 2 lows, but they're unequal ranges. The tidal range isn't similar. Sometimes they can vary from 4 to 5 feet. And then in areas where there's maybe, like, think the Mediterranean or further inland, less interference of large oceanic currents. Think of the Gulf of Mexico, the Mediterranean again. Those experience usually diurnal, so they just have 1 high and 1 low per day. Then when you get closer to the poles, like the North Pole and the South Pole, then it gets even, you could have a diurnal day, and then a week later you can have a mixed semi-diurnal. There's that common fear of being up in northern Alaska where you think you're above the high tide line, and then you wake up in the middle of the night and your sleeping bag's covered in water, and you're like, oh, I thought I knew when high tide was, and it's just an extreme event. So for me, it's easiest to think about this exchange of volume and how intense it is through looking at this cosine curve. So what we're seeing is height over time, right? And in the far left hand at the top is diurnal. So you see that 1 bump, and the top, the crest of that bump, that represents high tide, and the trough, that's low tide. Okay? Kind of like looking at a sound wave, right? And then on the right, we have semi-diurnal. Think coastal South Carolina, right? We're coming up, and those 2 high tides that we experience during the day, they're going to be around the same height. And then below, we've got our low tides, roughly similar. Okay. And we're getting 2 highs and 2 lows. So that's over the course of 24 hours. And then we've got 6 hours between that trough and that crest. So that's 6 hours before the tide reaches that next exchange. Okay. Then below we have mixed semi-diurnal, what we have on the West Coast here. And that's where you see that depiction of, yep, there are 2 crests, there are 2 little tops of the hills, but they're different sized hills. And there are 2 troughs, but they're different sizes. All right. So now we've covered a lot of the basic and intermediate tide terms. Let's look at the currents and how they play into it. So the tide is the up and down, the currents, the back and forth. Okay. And a current, I know there's some whitewater folks coming in, they're like, whoa, current goes a long way. So there's lots of different types of current in hydrodynamics, but what we'll be talking about mostly is reversing current, okay? Current is just the movement of volume of water measured in knots, okay? And reversing current is just like what it sounds. It's going in, it's coming out. It's flooding, going in, and then as it drains from the estuary or the inland tidal basin out to the ocean, it's ebbing, okay? And I want to mention here rotary current. Some of you guys may have heard of this term. It refers to current that can flow in any direction. It's not really bound by a certain predictable time. There are variables of the weather, other tidal happenings for reversing current, or swell and how large the energy of the ocean is at that given time. Rotary current we often experience pretty far offshore, or even in an exposed beach where you have a rip colliding with a longshore current. And then you have, it's all changing due to a low pressure system. So we're not really going to be diving into rotary current, but we will be diving into reversing current because that's what affects us most as paddlers. So the flood, just to cover that again, the flood is associated with rising into the inland area. And then max flood is the fastest. So that's when the current is fastest, when a lot of that volume and that momentum from that volume is fastest. So that's what we call max flood. That's when you can expect the currents to be strongest for that tidal exchange. And then we have the ebb. Thinking of that wave, that giant bulge receding, that ebb also has a max ebb. So that's when you can experience the fastest current for the outward exchange, that water being sucked back to the ocean. Okay, I'm very gesticulate if you guys haven't noticed. So what does this mean? What does this mean for us as paddlers? So a big reason why we need to look into tides before we go is just to know what's accessible, like what can we expect. So this is something that maybe some people are familiar with. This photo is, it's called mud flat rescue. And I learned recently that it's actually its own class of rescue for the Coast Guard. Who knew? It didn't just happen to us, it happens to a lot. So it's important for knowing the height of water where you intend to put in, where do you want to launch from, and also where do you want to take out. Throughout your day, are you going to have to add more distance to your day because there's a shoal that is exposed that you didn't account for, or a mud flat that you can't, get your boat over? So these are all things we need to take into account when we're planning our paddles. And then you also want to think about it if you're exploring the open coast, wanting to go through caves, arches, is there enough clearance for me there? If there's a favorite feature you have for rock hopping or rock gardening, is that feature going to be completely underwater by the time I get there, or will it be low enough for me to enjoy it? And in some areas, the tide also impacts the intensity of the waves or the swell. So thinking about if you're going to a beach to surf, that's a factor as well. So we also conversely want to know about the current, right? When I'm paddling, which direction is it going in, how fast, and when, right? Those are the essential questions. And not only do you want to know what the current is doing and the timing of that to preserve your energy so you can spend it on doing more fun things like exploring, but you also will sometimes want to know so you can find tidal rapids. Like a lot of you have played in Yellow Bluff, or standing waves that happen in various tidal regions, right? It's where you have an overfall of water over a feature, like a shallow feature, and a constriction of current, or let's say you have an opposing wind, and then you have that current that's going the opposite direction of the wind. You can get some fun standing waves or chaotic waves that are fun to play in. And something that I find super fascinating, especially for my Bay Area paddlers, is they've measured that there are 400 billion gallons of water that rush through the Golden Gate every day. So that's 400 billion gallons coming in and out, right? Not just in one cycle. I think it's measuring the movement. And that's why there are all these projects to look into building a hydroelectric energy generator under the gate, because there's that much energy coming from the movement of the tides and the current that they cause. Of course, we all know that they didn't do this. They built the Bay model and they're like, I don't know, this is a good idea. It's still on the table, but just to put that tidal exchange into comparison. So the Mississippi empties 139 billion gallons into the water, right? That's a lot, but it's not 400 billion. So no offense to Southeast paddlers, the Mississippi is definitely to be reckoned with. I'm just completely in awe of just the amount of water moving. So how do we measure it? So it's easy. I just want to give you guys this equation. You're free to use it anytime. This is a joke. It's easy. Just calculate using this. No, nobody does this. I just copied and pasted this equation from the NOAA website, the National Oceanic Atmospheric Association. And this is the actual formula they use when predicting tides, but I find that interesting. And then each place is a little bit different, given any rivers that special tidal basin features. But a lot of people ask, like, whoa, how can they predict the tides? And thanks to Copernicus and Galileo and Newton and a lot of other people, we have this formula that was mostly developed in the early 1800s and has been used since then to predict the tides. So, do I use this? No. Do most people use this? Maybe if you're an oceanic physicist at NOAA, but most people use these. So these are my best friends here. On the far left, you see the tide log. That is an amazing resource. It's kind of like the farmer's almanac of the water world, right? Not only does it tell you what you need to know, but it helps you understand why, cosmically, astronomically, what's going on to cause those tides. And there's some really great MC Escher graphics to go along with it for extra measure. But then you have my favorite modern tool. I know there are a lot of apps, really great apps out there. I find that TideGraph, another talented coach, Bill Vonnegut, introduced me to it a while back, and it's been my favorite. I find it's very accurate, especially for the Bay Area, and it works across a lot of platforms, and it's really easy to use. And of course, just to note, in the US, the authority for these two resources and most is NOAA, the National Oceanic Atmospheric Association. So they are the ones who are making these predictions that are localized depending on where you live. Awesome. So how do we predict them? How do we use these tools? And how do you even begin to approach them? So I've taken screenshots and photos of the tide log, that great resource. It's like the Ocean Almanac, to help represent what we're looking for. And big shout out to Basque. Basque has a lot of great resources online, and this was a diagram from Basque. So when we're looking at a particular day and we're looking at just the tides, we first want to know when is high, when is low tide. Okay? So here we can see the high tide is represented by that first bump. It's 6 feet and it's happening around 1 a.m. Right? Then we have our low tide, and that's happening around 7:29. That's negative feet. Okay? And then we have our next high tide and our next low tide. But it gives you a really easy way to reference when it should be and where. So on this note, there's a very important caveat I want to point out here, is that this isn't, you can't just put in anywhere and expect this to be true. This is usually a reading for one of the most common places or a central reference point around where you paddle. So for this tide log for Northern California, they've chosen right under the Golden Gate Bridge. So this is the tidal readings for Golden Gate. So this means near the Golden Gate Bridge in San Francisco, this is when you can expect the highs and lows. And right below, you'll see some current readings. We'll get into that next. But just know when you're looking at a glance, this may not be where you want to paddle, and you may need to make corrections. And we'll talk about that a bit later. Okay. So another caveat I want to point out is the tide log and the resources I recommend have taken into account daylight savings, but there are some more rudimentary tables and predictions that are depicted in tables, just called tide tables. And you can get them from bait and tackle stores or West Marine and coastal areas. Sometimes you can find them in gas stations. Make sure you check in the index whether or not they account for daylight savings time, because a lot of tide tables don't account for daylight savings time, and you usually need to add an hour if it's past March and before August. Those dates have, or sorry, not August, November, the daylight savings times. All right, but Tide Log has taken that into account. Tide Graph, they do the math for you. That's why I love them. All right. So we looked at our high tide and our low tide. Now we want to know about the current. So we want to know when is max ebb for the time that we'll be paddling, and when max. And not only do we want to know when it is, but how strong it is. So in the tide log, the way that's depicted is you have that y-axis here, sorry, the x-axis here of time. And then there's like a little caret pointing up, showing you when in that tidal cycle over time you can expect the max ebb, right? And when you can expect the max flood. And it shows you in knots what that will be. For this, it depicts both for right under the gate, which is why you see like, whoa, 4.8. Like, I heard the average paddler can only go 3 knots. That's a pretty mighty, that's a mighty ebb to be fighting coming back into the gate. But then you're like, but why is it saying 2.8 knots max ebb later? So above, that's under the gate. Below, that's the line for Carquinez Strait. So further, deeper into the bay, it takes a lot longer for all that water to either empty out or come in. There's a delay there. Okay, so we've looked for our max ebb, our max flood, how strong and when. So let's say, okay, we have that information, but I don't want to paddle under the gate. Like I just want to paddle in Berkeley. Where can I find that? So in the tide log, you can look in the back and they'll offer you corrections, right? And they'll offer you both current corrections and also tidal corrections. So the current corrections are on the left here and the tide corrections are on the right. I didn't want to get too deep into this because it can get pretty variable, and the math is honest for me, like, and for most people, it's pretty simple. You're just adding time, subtracting time, and you're either adding a current reading or you're subtracting it. Okay, so there's sometimes a multiplier, which is signified by an asterisk. But for the most part, there's going to be a plus or minus, and then there's some great directions there for how to do that math. But you can correct that based on where you're going to be paddling. Okay, so there are some rules of thumb, some quick tricks to think about, right? Some people may have heard the rule of 12ths for predicting approximate volume. Some people may have heard of the rule of thirds, right, for predicting approximate speed. But before we get into that, I want to just acknowledge some baseline. Flooding, ebbing, that's usually a 6-hour cycle, roughly. Sometimes it can change, but it's roughly 6 hours. So you have your low tide, and then you have maybe a 25-minute slack or a 10-minute slack. And then after that, you have another 6 hours. So let's say you are going out later than expected and you only pulled the low tide for when you expected to be on the water. No worries, you can always just add 6, and that's probably where the next low or high tide will be, because you have 6, 6, 6, 6, leading up to 24 hours a day. And remember how we were talking about the lunar day being 24 hours and 50 minutes? So a lot of people know that the times for highs and lows, all of those that timing shifts 50 minutes approximately every day. So if you had a high tide at 2 p.m. today, tomorrow you could expect it to be around 2:50 or 3 p.m. or a little bit after 3. And the reason for that is because the lunar orbit is a little bit longer than our solar, not orbit, the lunar day is a little bit longer than our solar day, which accounts for that shift, right? So if you're on a trip and you maybe didn't have readings for the next day and you're staying out a day longer, you can predict that just pushing everything approximately 50 minutes forward. Rough, okay? All right, so there's also a way to approximate current, right? So max ebb and max flood happen usually 3 hours in, okay? So think about it like turning on a faucet, okay? When we're leaving slack tide and that tide's coming in, let's use the flood. Think about the faucet just said. The first hour, we're thinking maybe 50% volume, right? Then we're gonna add another hour. We're gonna, or 2 to 3 hours, we'll add even more, right? We're gonna maybe notch up to 90% volume. We're gonna turn the faucet, let 90% off. And at the third hour, we're gonna be like, whoo, 100%. That's the rule of thirds. So the first hour, you can expect around 50%. The second hour, you can expect around 90%. And the last hour, 100%, right? The last tip of the hour. So it kind of forms like a pyramid. And at the tip of that pyramid, you have your max, right? And that's what this diagram is showing you here, right? And then what I also want to note is that, and I'll cover this more in a slide, is that a lot of this, you can do a beautiful job of preparing, and then the predictions can be accurate, but you can have a strong rain or a big storm and everything is thrown off. So I say that because prepare for the unexpected always when it involves the ocean and the tides and currents. It doesn't mean you're not doing a good job. It means that there are so many variables at play that despite your best efforts, there was a wild card there. But for the most part, getting back to a cheat for the currents, you can expect that max current at that 3 hour mark, and then it'll start to decelerate and they'll be turning the faucet back off, the faucet of current. All right, just as I mentioned, be prepared to have everything turned on its head. This has happened to me more times than I can count, where I'm sitting there and I'm looking at the tide log or my app in my hand being like, it shouldn't be ebbing right now. It shouldn't be ebbing. Why is it ebbing, right? And there's so many factors. And the most common wild cards are extreme tidal events that have happened recently. Sometimes there's even like a shifting of the tidal basin, okay? Strong winds, especially coming from offshore, onshore. If you have an inlet, it can hold the water in at certain times and delay that release, whether it's ebb or the flood coming back out there. And then also high pressure systems and low pressure systems, especially if you have a storm cell, a large storm cell moving off the coast. We typically experience this as storm surge during hurricanes. That's a macro example of this, where everything is just doubled and ballooning and swelling from that pressure on the water. And then also, if you have large swell energy, so on the east coast of Florida, there's inlets, and there was one day where the water was kind of being held in, like the high tide was being held in by the waves at the mouth of this inlet, and it was siphoning it further inland rather than releasing it as an ebb. So just keep these trump cards in mind. I wish we could get better at having an exact multiplier when they happen, but because every event just has so many variables unto itself, it's very hard to predict. But always keep a log. Try and notice every time you paddle what's going on. You should be better off too. So this is just a bit of practice. I know a lot of y'all may have been familiar with this. I'm looking at next Sunday, May 17th, and I want to paddle. Right? First, I want to establish my ideal timeline. And let's say, for this example, I'm planning a paddle out the Golden Gate Bridge to the Marin Headlands. So first, I'll ask myself, when is it going to be high and low, especially during the time that I want to paddle? So I see a 4-foot high tide at 9 p.m. or 9 a.m. And then I see the next low isn't until around 2:50, 2:49. And they're not that extreme because we have neap tides happening right now. So it's not that extreme cosine, it's more leveled out. And because of that, there's less volume being exchanged, the current is also weaker. So I'm seeing max ebb. Let's say if I want to do a morning and afternoon, paddle at the start of the morning and in the afternoon, max ebb is happening a little bit after 1 p.m. and it's only 2.5 knots. So if I were to try come after the max ebb, at most I'd be fighting maybe 3 knots, accounting for maybe recent rain flooding out of the Sacramento, compounding that ebb flow, compounding that current, right? So it looks like if I wanted to time my paddle and I want to take advantage of that flow of current, so I want to take advantage of the ebb to like give me a free ride out the gate, I'd probably want to launch a little bit after 9, maybe more like around 10, okay? Catch that ebb, still have some current, plenty of time to play and some features and the headlands, and then come in maybe a little bit before 2:30 or around 2:30. And so I'm paddling around slack. So I won't be fighting much current coming back in. And if I wanted to ride the flood, I could wait even later, maybe have a long lunch, take a nap on the beach, get back in my boat, and come in around 5 or 6 and just be super lazy and ride the flood and never have to fight the current. That's not about me. I love taking it easy. So that's how I would think about ideal timing, especially looking at a tide log. But sometimes you want to get a little bit more exact, and I want to introduce you guys a little bit more to my best kept secret and my favorite tool that I use. I'll definitely use this in combination with tide log because I love having that overview of what's happening astronomically and the trend of the volume. But if I want to zero in on a particular day in a particular place and not have to do all the current corrections and the math associated with it, I will use tide graph. So in the bay, it offers you localized tidal reading stations that will give you the exact current at any cycle in the flood or ebb that you want for any particular tidal station. So you could maybe be going around Richardson Bay, like deep into Richardson Bay, and get a tidal reading up around Corte Madera there. Or I want to be going closer to Rodeo Beach, outward there. So I can get automatically to select that tidal station, and then the day I'll be paddling, and I can not only see that beautiful graphic representation of the volume, but you can also see just at a glance for that particular station, it does all the math for you for the max flood. And it'll also show you, let's say you'll be crossing an area during not max, but in between max and slack. You find exactly when you expect to be there and see the exact, not exact, because you know there are so many variables that happen on a given day, but a really great calculation of what you can expect tide and current wise. A caveat for this, I do coaching on the East Coast as well. I've noticed there are fewer current stations. It'll give you the tide readings at a lot of places, but for areas that are maybe less trafficked or there's less consequential currents, sometimes you'll find a dearth of current stations to pull from. But especially here on the West Coast, they're pretty robust and well accounted for. And in like large estuaries and really important waterways on the East Coast, like the Chesapeake or large bays, especially where there's shipping traffic, you can find pretty accurate readings. So that's my favorite tool to use. All right. So getting past just predicting and reading, there are some uses you can use, some ways you can just look and read the water at any given time to take advantage of features in the current. So this is where a lot of my whitewater friends who are tuning in might be like, oh, I got this now, like knowledge checking in. So in places where there is an extreme current, or when I say extreme, I'm not talking like 14, 20 knots. I'm saying even as much as like 2 or 5, you can expect eddies to form, similar to what you would expect in a whitewater river. So an eddy is an obstruction of that current. Oftentimes, eddy or a reversal in there. So even though the current is coming out, let's like say it's going that way, there'll be almost like a wisp of current going in the other direction. So in the Bay Area, we experience this a lot in the headlands and also around points where the current is obstructed, and you can get a free ride. It's not completely free because it's not as strong typically as the main current, but there is a back eddy that can help you gain speed. So you're not often fighting unless you're doing a crossing beyond that eddy. So a lot of the ways that I use this is because I've started to race more and I'm trying to get more strategic with gaining speed. And so even when I'm racing and doing just playing with my friends and thinking about conserving energy, sea kayaking, knowing where the eddies are, taking advantage of those eddies, and taking advantage of the back eddies, feeling where that current is strongest. And in the ocean, we have lots of debris, flotsam. So an indicator of where those back eddies are is you can see where the debris are flowing in that eddy, in that feature there. And when you're fighting the current and there's no choice, it helps to stay shallow, right? Because when you're in deep water, that current, that water builds on itself, and it's kind of like a lot of weight and volume moving together. But when you're in shallow water, even though there's current, think about dropping water down sandpaper. The friction just slows it down, okay? Same thing happens with a reversing current in the ocean. When you're shallow, that current is less strong. So if you're fighting in the middle of the channel and you have the option to hug the shore, and you're tired, always hug the shore if you can. Take advantage of that slower, shallow water. Conversely, if you're wanting to catch the best ride possible using the current, stay deep. If you can avoid boat traffic and stay in the middle of the channel, that's where you're going to get the maximum push, the conveyor belt that we all love. All right, so hopefully we've covered our goals here. And I also have noticed that on the next slide, I have a joke that I forgot to remove, so I hope it does not offend anyone. But I wanted to end on the slide just to note that there's a lot of really fun, interesting math that can be done in determining ferry angles and vector angle solutions using the current and crossings. But I wanted to make sure we capture all of that elemental information. But this is just a starting point, and I'm excited for each person's Tidal journey. And the last thing is I wanted to give a big shout out to these resources. And here's my joke. You can tell people how was your presentation? You can be like, well, I learned today what causes the high tides. Seaweed. So these are my favorite resources that I've reviewed so far, and I'd be curious to know yours. If you wanted to email me afterwards, I'd love that. The tide log, of course. Kayak navigation is fundamental. A lot of people have this book in their library. I also want to give a huge shout out to Tides, this book by Jonathan White, especially if you're really interested in the history of humanity and the anthropological side of tides. I really recommend it. He puts the tagline is the science and spirit of the ocean, and it's heavy on spirit if you need that. All right. Well, now be gentle with me with your questions, but I welcome them.
Thank you so much, Laura. That was extraordinarily informative, and I definitely feel smarter for that. And this will be something that I'll be rewatching again. So right now, what we are going to do is we are going to open up the floor to a Q&A session. The easiest way we found to do this is if you have a question, go ahead and put it in the chat and I'll moderate. So I'll go ahead, I'll call on people, I'll unmute you. And then once you've finished asking your question, you finished chatting with Laura, just in the essence of keeping the flow and being able to call next in a timely manner, go ahead and mute yourself back up. So, you know, in case someone's in the background talking about what they're making for dinner, we all don't need to hear about that. Anyways, so we're going to start with Marie. Marie, just, I'm going to find you. I'm going to unmute you, and then you're going to get to ask Laura your question.
Hi, Laura, can you hear me?
Yeah, I can hear you.
Really enjoyed your presentation, and I learned a lot about these tidal currents. But I'm a newbie when it comes to the ocean. I'm actually a whitewater kayaker, and I know so little about the ocean that I have trouble fathoming why it's dangerous. I know that's dumb, but it's the Dunning-Kruger effect.
It's
So
not.
I was hoping you could tell me, like, what sort of trouble I need to watch out for when I go onto the ocean.
How much time do you have? I'm just kidding. That's an excellent question. And you're making me smile because every time we went over a whitewater boater to the ocean, I'm just like, yes. So to answer your question, there are myriad dangers that should all be taken seriously. But I don't mention this to scare you away. It's more about building awareness. I think it might be helpful for me. I'm gonna put my whitewater kayaker hat on and try and speak to maybe some familiar consequential features that you've experienced on whitewater rivers and kind of project that difference with what skills and mindset you would need on the ocean. Because this is something I think a lot about too. So when you are whitewater kayaking, the rivers are pretty navigable, right? You're not really gonna get lost between one shore and the other. But in the ocean, it's really big. So I think navigation becomes pretty important. And I actually would put under the umbrella of navigation what we discussed, tides and currents. So it's pretty important not only to be aware of the up, down, and current and the flow of current and the tides, but also where you are at any given time, what features you'll be looking for to know that you're not drifting out to where you don't want to be. In some areas, everything, once you lose sight of buildings, everything starts to look the same in this kind of haunting way where you're like, uh-oh, where am I? So I'd say navigation is really essential, and learning to know where you can go within the bounds of your navigational knowledge. That's definitely a critical difference stepping from whitewater to the ocean environment, where you can wind up getting in a lot of trouble really quickly. Another thing to really be mindful of are rescues. Right? In the river, the shore is, granted you might be in the middle of a rapid, but the shore is usually pretty visible, right? There's some times where you're gonna be a mile or even 5 miles from the nearest place where you can stand up. So paddling with a pod or being able to have a self-rescue that's reliable, and that doesn't have to be a roll. In sea kayaking, our boats are designed to be pretty easy to self-rescue even if you swim. I should use easy in air quotes because they're not always easy, especially in different environments. But I definitely want to say that there's a huge emphasis on rescues and making sure you paddle with people who understand how to rescue you efficiently and quickly. And another big factor is we have so many variables, especially if you're paddling on the West Coast. Learning in bays and estuaries and protected areas is ideal, because once you go out to the exposed ocean, the swell here And the waves can get really big. And compounding that with the current and compounding that even more so with shipping traffic, you can imagine how quickly it would be and easily it could be to get into trouble. So I think starting from a place of understanding the rescues, understanding navigation and where you stand with your navigation and your skills and what that gives you access to, and then also understanding ideal venues for your skill set and also balancing with fun, because sometimes big swell is what you want as you progress and you're like, let's go. Sometimes big swell is not what you want. So for me, those are the three things coming from the whitewater world to sea kayaking or hiking you really want to be most mindful of when it comes from consequence. I hope that's helpful.
That is very helpful. And for someone like me that came from a strong whitewater background and then has been consistently learning to develop my sea kayaking and understanding the ocean, there's a lot going on. And so for me, you may feel like you can handle a boat really well, and then you add all these other variables and it's like, okay, never mind, I don't know how to kayak. So find someone, like Laura that, really understands what they're doing. And yeah, because things can happen pretty quick out there, even in, like Tamales Bay, things can happen pretty darn quick.
And on that note, sharks should be at the bottom of what you fear. I find like whitewater boaters are always like, but the sharks. No, don't worry about the sharks.
I didn't say it. I didn't even say the S word. Okay, Zoe, you are up next.
Hi. Thank you. I'm so happy to be thinking about all this because I'm kind of stuck far away from the ocean right now. But I was hoping, Laura, you could just take a few minutes to talk a little bit more about slack tide. I feel like, I understand the idea of slack tide, but I've kind of read and heard different explanations of it.
Mm-hmm. Yeah, I was worried someone was going to ask that question, to be honest. So slack tide is one of those things that's super variable, not only by where you are in the world, but even in the exact same spot with different seasons, different times of the tidal cycle can vary quite a bit. But from a broad survey, especially of US waterways and coastal environments, it is that time when, let's use full going into ebb, where all of the water coming from that tidal wave has completely inundated the tidal basin. And then think of it as a wave, like that giant wave is retracting now as the earth is moving and the sun is moving away, right? Kind of like a magnet bringing that little magnetized sand across an Etch-a-Sketch, that's kind of the same thing that's happening. And so it really, to get to your question of the slack and the variability, when you think about it from that standpoint, it really depends on the volume that's being moved and then also the shape of the tidal basin. Okay. So there are some places in the world where the tidal basin is shaped in a way that slack always experiences a degree of current. I wish I could tell you there was a hard, fast rule, but there's not. And there are other places in the world where slack is like consistently 10 minutes every day. It's Old Faithful. There we go, 10 minutes. We're back on ebb.
So it's a matter of getting to know it where you are too.
Yeah, getting to know it where you are. But I'd even love take it a step further if you're really curious about it and build your own compendium of local knowledge. So not just learning for what the books say it is that day, but going out and observing after a day it's rained. Like, how did the rain affect what the slack prediction was? And get scientific with it and see, okay, here's what predicted. Here are the factors that could influence this. Did I observe this as predicted? And what's my theory or my hypothesis for why not? That's how I would approach it. And then try and find someone connected at NOAA to explain it to me if I notice a variable that I don't understand. I hope that's helpful.
That is helpful. Thank you.
Yeah, it's a great question.
I feel like people think it's just this, the water's going to completely die down and be calm, and it's like that. I've never experienced that. So
No, and I told an anecdote to some friends today, even that there was a period where we had really intense rainfall for a long time, and we were going kayaking, and it was out the gate, and we ended up not going out the gate because there was no flood the entire day. The rain had caused that was draining into the bay was so intense that there was no exchange. It was just ebbing all day. No slack, no flood, just ebb. So
that's amazing.
yeah. But,
Thank you. Thank you.
yeah, thank you.
Thank you, Zoe. Great question. All right, Paul. Paul, you are up next. Hello, Paul. Paul had a question on mean sea level. Paul, are you still out there? Oh, his microphone won't work. Okay, so I'll read it. What is the distance referred to feet of tide? Is that mean sea level?
So that's a really great question, because you know how we have when it says like a negative tide, and you're like, well, negative to what? And this is really important because there's usually a local reference point for what that tidal range will be. And if you look at a chart, in sea kayaking, it's always a chart, it's not a map. That's the one giveaway that you're not an OG sea kayaker if you call it a map. So you have your chart, and you'll have your depth readings, your soundings, all around the waterways. And the sounding is a measurement of mean low tide. So you're, taking all the averages. I know mean is different from average, but it helps me to think about it. It's just like your run-of-the-mill low tide, okay? And it's purposeful because they want that to be a baseline. They don't want you to expect too much, especially boats who need more clearance because of their keel or their propeller. They're just heavier, deeper water, longer water line, deeper water line. But your tidal reading is going to be plus that reference point of mean low tide, or minus that reference point of mean low tide. So that's a great question. And you can find that on your local chart. That make sure it's a NOAA chart, that acronym, most people know NOAA now. Make sure you're using a NOAA chart and a NOAA tidal reading, or a tide graph or tide log, because those are the corresponding references. I hope that answers your question.
Paul, give us a thumbs up if that's good for you.
Thumbs up. Thanks, Paul.
All right. Thanks, Paul. Awesome. All right. Next up, we have Pauline and Henry, who have a question for you.
Hello. Not to get too specific with a certain layout, but we can like talk about this example and then broaden it to general. But we live like in Point Richmond, and there's Brooks Island near our house where you can paddle down. And when we're trying to like assess the currents and the tides, we go by, there's like a marker at the Richmond Bridge to tell you, how fast it's flowing, what way. But we're kind of sitting there like, is this super relevant? Because we're staying kind of close to shore and like going what we imagine is more parallel to like the bay flow. So we don't ignore it. We still try to figure out, ebb and flow. Let's make this work for us. But what's your advice on, I don't know, if it feels like you're not right under the Golden Gate Bridge and it's not huge impact and you're more distanced and maybe not in the heart of it. Yeah, we're kind of curious on your input with those kinds of situations.
Yeah, I think that's a great question. Because if I'm being like just listening to you talk about how you go about it and how much credence you give that reading, that's how I approach paddling in, let's say, Richardson Bay. Richardson Bay is pretty shallow, it's pretty silted, and it's because of that, and it doesn't have like a strong river flowing through or like outlet there. even though you have a really strong ebb happening, it's kind of cut off as this kind of outward inlet from the rest of that tidal exchange happening in the bay. So I very seldom will hop on and like do a paddle around Sausalito, having timed it around the currents or the highs and lows, just because I know, okay, it's really shallow. If there is any discernible current, I'm likely going to be able to overcome it and overpower it. If I step out of, a lot of times there's almost the change in watercolor from Richardson Bay to where you enter into that water that's coming in from the gate or flooding around Raccoon Straits. When I'm going out there, if I'll cross over to Angel Island, definitely time it around the tides. But per what you both are saying, I would look at the water of where you're going to be paddling, and again, build that compendium of knowledge, and maybe go out 2 really interesting times that I'd be curious to experiment with. Go out when you have that new moon or that full moon and see what happens, especially when we're predicted to have some strong current under the gate, and see what's happening where you are, not putting yourself at risk by like, you know, going any channels or having to fight too much. And I'd also be curious, because you were further up in the Delta, closer to the Sacramento like outlet, after we've had strong rain, I'd go and test that as well, because those are the 2 occurrences for where you paddle where I would want to be super mindful, and just to build a, you know, a catalog of what that looks like would be helpful. So yeah, cool. Great question.
Thank you.
Yeah.
Awesome. Thanks, guys. All right, Marie, back to you.
I was hoping to follow up on your story about the day you intended to go out the gate, but the rains made the flood not happen, so you didn't. I'm interested specifically in your decision process to not go out the gate and how it was informed. Like, how did you notice there was no flood with the heavy rains?
That's a great question. So in terms of can I tackle how did I know first and then go into my decision process?
Yeah, and maybe at what point you realized it wasn't a good idea? Like, were you already on the water, etc.?
The no-go call.
Yeah.
Yeah. So what we had heard, so we didn't just look at it and see, like sit there for 24 hours and be like, yep, didn't see it, didn't happen. We had heard from other sea kayakers that there had been, because of all the rain and we'd had consistent, like a week of solid precipitation, especially in the mountains. And that corresponded with tons of snowfall around the Sierras, that people were already noticing either a delayed flood or maybe a slight short flood. And to the point where we were deciding, we already knew to look out for it. So we had timed our paddle on that day to put on when we could expect to see if there was a flood, right? We're like, okay, we'll put on at max flood and see what's going on. And if we paddle out there and we're still getting pushed out the gate, that's a pretty great indication that it's not happening today. So from my recollection of this day, and this was back, I want to say in 2017, 2018, the winter we declared the drought over a little prematurely. Not only did we, like before we even put on the water, you could see that usually there's this nice bluish green hue to the bay where we are. But that day it was very brackish. It was almost brown. So already we could tell, okay, with a flood, there should be that fresh ocean water, fresh meaning like unsilted, salty, beautiful salty water coming in the gate. But all we saw was this like river water, pretty brackish river water. So number one, that was an indicator that we didn't have that exchange. When we got closer, we could see that their buoys and their other markers, they were still keeling towards an ebb. So we could tell in that way. And then once we put on, we could see the eddy lines. We could see and feel that it was still ebbing, even though we looked down at our tide logs And this was the exact spot and the exact time called for max ebb. And in that situation, we were like, well, let's just make the best of this, and we're going to see if we can find some tidal rapids. And we did. And so we adapted to, instead of going out the gate, to our plan B of going to this area called Yellow Bluff, where we can sometimes expect chaotic standing waves in a tide race, and just played around there as safely as we could. But it was also interesting, not only did we use all those indicators, but I built up, I know this is, I don't advise anyone to do this, but I like tasted the water. And of course, we're right by the ocean, and it wasn't very salty at all, which was very eerie. So the no-go point was made once we aligned all of those indicators, pairing it with what we had heard from other kayakers. So that's how that decision was made.
Nice.
Yeah.
Awesome. All right, next up we have Katie.
Thanks a lot. I appreciate this talk so much. I've learned so much. I'm seeing if I'm muted or not. One question we come up with on the East Coast, and we don't have the tidal extremes of the Bay Area, but the phenomena that the water level, the high tide and the low tide is going at one pace, but the direction of the current is different. So you can have the highest water level, but maybe the tide is already going out. So you have an ebb during a high, and the direction of the current and the level of the water are different. And it's hard to visualize. And it's, you know, I can read it or see it, but it's also hard to explain since it's hard to understand. Do you have experience with that? And do you have any understanding of the separateness of those systems if you have experienced that?
Oh yeah, and may I ask where you are based?
Baltimore, so Chesapeake, which the Susquehanna is dammed, so we don't get a lot of action here, but we can go out to the Atlantic from time to time. But so.
Yeah, that's an excellent question. And really touches into the shape of the tidal basin and how large of a tidal basin this wave is inundating, and then also any sort of complicating, I should say complicating, but like compounding volume from rivers or inlets, or even just, you know, areas where you're having potentially a lot of rain that's quickly coming into the estuary. My favorite way for visualizing this, if you have a tide log, which I know they make for the Chesapeake.
I just ordered one while we were talking.
Yay! That makes me so happy. You're gonna love it.
I know, I can tell. I looked at the sample pages. It looks like it's easier to be with than the digital.
Yeah,
form.
100%.
Yeah.
And in the way back, a page that I wish I had now screenshot for this exact question, but when you get your tide log, if you go all the way to the back, it'll show you a diagram, like almost a chart overlay of the bay and the features, and little arrows that show the flow of current at different phases of the flood and ebb. So you can see for what the current all over the Chesapeake will be doing at an hour into ebb, 2 hours into ebb, 3 hours into ebb. And then it'll give you these helpful arrows where you can see.
You can't tell where it's coming, which way is high ebb and which way is flood in some of these crooks, in some of the geometry of it, right? Without knowing that.
Oh, it's super helpful. And also knowing, like, historically 3 hours after ebb at the entrance to the bay, oh, it's still flooding over here. And a lot of that has to do with like the shape of the tidal basin and how far from the inlet that is, and how long it takes for that water to drain out or like flood in. And it's really helpful for me to visualize where you can expect the delay to be the most extreme and at what stage of tide, like when typically you can experience that. And it gives you multipliers too. So not only will it say 3.2 here and 1.5 knots there, and the direction, but it'll say you know, a multiplier of the max ebb given at the main reading. I know this sounds, if I had the visual,
Good.
it would be easier.
I don't mind a multiplier. I let it skim until I get the visual. How often do you coach out here?
So I only coach about twice a year at this point, but I'd love to coach on the East Coast more, but mostly in the Southeast where
Ashley?
we have
That's
roots.
where-
Yeah, Ashley. Yes. With Ashley and Dale and the Wave Paddler crew. So
Cool. All right, that's great. Well, I hope to find you when you come out here, or I'll come out there. But yeah,
yeah, let's do both.
That your currents are a little more spicy, I think. But that's cool. Good. Thank you. I appreciate this so much.
Yeah, thank you.
I'm glad you're enjoying this. All right, Kate Hawthorne, welcome to the show. Kate just gave an outstanding presentation the other night on the whitewater of the sea. So Kate has a question for Laura.
Oh, so Laura, excellent stuff. Getting into all that scientific stuff. Wow, very well done. A question for you, something I have trouble with, I don't think I really understand it or know it well, is the California current. And I have an app on my iPad called iTides, and I just look on that and go with that. But for me, it'd be helpful if I just had a good sense of, you know, when to know to expect that current. And for those of you that aren't familiar with it, we've been out paddling, and it's like, we feel like we're paddling uphill or something. We're paddling on the coast and there's no wind. And then I get home and I look at, oh yeah, the California coastal current was like 2 knots that day. And we're paddling against a 2-knot current on, you know, anyway. So any tips for predicting that?
Oh man, I'm curious, are you using Navionics when you're looking at these like offshore currents or like coastal currents?
No, it's called iTides, and it has, they have the tide predictors, like the tide station. Where we live on the Mendocino coast, I usually use Noyo River, which is right here. But then they have one that's out of Point Cabrillo. Salt Point is the next one further down, and it gives you that current that's happening. And I don't even know, they call it the California current. It's not really a longshore current, but just a way to estimate that without being dependent on the app.
Yeah, I think that's a great question. And that's what I've been, to my knowledge, I've been referring to it as coastal current and this like rotary current, because you're right. It's kind of, you'd think it'd be similar to a longshore going predictably, but it's less predictable. And this is maybe one of those questions where I have to research and get back to you, because I wonder if there is a consistent predictability with like a solid like variable that's the trump card on that. But from what I heard and what I've understood is that it's very regionally dependent until you get pretty far offshore. So similar to a lot of land masses, like in Taiwan, like Kelly and I, when we were planning our trip, the Kuroshiro current coming up and going towards Japan, that really only kicks in, like they said, 16 miles offshore. And I know it in California with our current here is very seasonal too, which is why like in the summer we have all that upwelling, because there's a shift in the current and the cold water comes up and then it kind of recedes in the winter, but the water's still cold. So I'm like, I don't know why. But from what I can understand, it's also very, until you get super far offshore, like maybe a mile plus for where we are, it's mostly dependent on the largest inlet that you're dealing with. So for what I've noticed, being around Point Bonita and then also Ocean Beach, is that current will be dictated mostly by that exchange happening in the gate, and combining and colliding with the swell. And then there's that secondary where there are all these mini outlets at the beach or creeks that are draining out, and then that can have a compounding factor. Sometimes there'll be like a strange massive rip that's all of a sudden like, you know, going out, where you'll feel, for me, I've been like, oh, I feel like I'm getting a boost, and all of a sudden I feel like I'm drifting off, and I'm like, but there's open coast there, and then I'm like being sucked a little bit towards it.
Yeah.
The wind, if it's blowing from the north, like the northwest, it also just, it's hard to determine like what's wind related and what's not. So that's a long way of saying I really don't know.
Ah.
Yeah, but it's a great question, and I really want to learn more.
Yeah, well, tides. I look it up there whenever I'm planning offshore journeys, but yeah, I was hoping for there is an easy trick. But
Yeah, and I'm excited for your surfing, your session on surfing as well.
sweet,
So
cool.
if
Good.
you guys can tune into that, best thing on the ocean.
Awesome.
Thank you.
Thank you, Kate. Thanks for joining us.
Yeah.
All right. So this is our last, I did a last call on questions. Yes, I saw your question, Katie. So before we let Laura go, we're gonna call her back on. And Laura, do you have any closing remarks? Anything, any last little things you'd like to say to our audience before you sign off for the day?
I'll sign off with another cheesy joke. Mel, did you hear about the score of the game between the ocean and the beach?
No, tell me about it.
Yeah, I heard it was tied.
Oh my goodness. Well, thank you so much, Laura, for being here. And that was absolutely phenomenal. Thank you everyone for attending. Please come back and see us again. Laura will be back on June 7th for Understanding the Ocean Wind. So everyone's favorite thing that they need to contend with sometimes. Laura will break that down and hopefully shed a little bit more light on this subject. You could actually tune in for an entire saltwater weekend. Kate Hawthorne, who was just on, is going to do a webinar on the surf zone. So you can tune in all weekend, June 6th and 7th for surf, and then back to Laura with some wind. For if you're into whitewater, we also have some other great, we have lots of great webinars. We're just going to keep these rolling until we can all just kind of go back to, you know, doing more kayaking and things like that, or we'll just keep doing them forever because the topics are pretty endless. So we do have a really great one that's applicable to whitewater and sea kayaking. Natalie Anderson is doing a fine-tuning the roll at the end of the month. And then we do have a family series that's sort of our special edition series within a series, dealing with family life and paddling and how to balance it all, and whether it comes to work and family and how do you still get to go out and have fun. Emily Jackson will be joining us from the East Coast, and then we'll have two presenters on actually paddling while you're pregnant and how to do it, how to deal with it afterwards. But we have so many great topics coming up. Please tune in, get back on the website, check it out. Yeah, we're having fun with this. We miss teaching oh so much, and so this is sort of helping us get our fix. So thank you everyone for attending. If you all want to hang out for 2 seconds, and just so you know, I will be sending you a link. We are recording this webinar, so I will be sending you a link. This was a lot of information, and so if you didn't furiously take notes, it's okay. You're going to be able to download this and watch it again and again. If you know of someone that missed it that would really be interested in it, we are also offering all of our archive webinars on our website, on our store page. And so you can go back through, they're all still $5, and you'll get the recorded webinar with the Q&A sessions. So come on in this, and just so you know that all this goes to support the coaches of these events. So we appreciate your support and your generosity. And thank you again so much. And give us 1 second. I'm going to share a screen. It's going to have all of Laura's information because it'll take us a day or so to get everything up to you. But thank you again, Laura, and we will be seeing you again soon.
Thank you.
All right. And there we go. Thanks, folks. Hope to see you again soon.